I would like to introduce Dr. Sowmya Vajjala, and she is here from Canada, joining us from Canada, where she says it's very cold. So Sowmya currently works as a researcher in digital technologies at the National Research Council, which is Canada's largest federal research and development organization. She has worked in the area of natural language processing over the past decade in various roles as a software developer, a researcher, an educator, and a senior data scientist. She recently co-authored a book, Practical Natural Language Processing, a comprehensive guide to building real-world NLP systems. Her research interests lie in multilingual computing and the relevance of NLP beyond research, both in industry, practice, as well as other disciplines through interdisciplinary research. Let's all welcome Dr. Vajjala. Welcome.
Hello, everyone.
Feel free to use your emojis if you're not visible to us. And then I would also like to welcome Kristy Phillips. Kristy Phillips is one of our students here in the College of Information. Kristy is a Ph.D. student in information science with a concentration in linguistics. She has a Bachelor of Science in Computer Science and a Master of Science in Interdisciplinary Studies with a focus on computational linguistics. Kristy's research focuses on building computational tools for low resource languages and bias in machine learning. Let's all welcome Kristy Phillips with another round of applause. Welcome, Kristy. Thank you both for agreeing to be here. And with no further ado, I'm going to hand the interview over to Kristy so that Kristy can ask our guest questions. Now, I do recommend before we start that you put your view, your Zoom view to speaker view so that it feels like we're sitting, in a room together with a comfortable sofa and Kristy's asking questions and Dr. Vajjala is answering them. So that's my recommendation if you would like to do so. I'm going to do that right now for myself. Okay, take it away, Kristy.
Hi there. So Sowmya, first, I'd like to thank you for being here and thank you for answering our questions today. I think we can get started then. The first thing I wanted to ask was if you would share your personal journey in the field of computational linguistics with us.
Yeah, sure. I mean, I don't have a lot of twists and tales in my journey. It's more straightforward, actually. Like my background is in engineering. I did my bachelor's in electronics engineering, but I started working as a software developer, which was when I learned about NLP. I was very fascinated at the time about speech-to-speech translation. So I thought, I never worked on that topic after that. It's a different thing. But that made me apply for a master's program. And after that, I've been pretty much doing NLP, whether I worked in a software company or whether I did research. So I worked for some time, then went for a Ph.D. Then I was in the US. I was teaching at Iowa State University for some time, for 2.5 years. And then I came to Canada in 2018. And yeah, I mean, I worked for a year as a data scientist in a company in industry, and then I now work for the government. But all the while, I've been working on various NLP problems. So I'm one of those fortunate people who actually studied what they currently work on.
So do you have a preference for academia or industry or government work? Do you?
I think, I mean, when I was working in at Iowa State, I thought being a faculty member is the best job in the world. When I came to industry, then I realized, this is not that bad either. But right now, I think the job I am in, I think this is the best job in the world because it gives me the best of both worlds. Occasionally, I do guest courses and things like that. I also work with industry people, but I also work on my own research.
Yeah, I can see that. Okay, so in your current role as a researcher in digital technologies at Canada's National Research Council, what are the main applications of your computational linguistic skills?
So there are, I think, primarily two sides to what we do at NRC. I mean, most of the researchers do at NRC. In terms of my own personal research agenda, like I'm primarily interested in working on problems that have some kind of direct application. Like say currently, for example, I'm working on doing something called named entity recognition, which is more like extracting names of people organizations, addresses, locations, and these kind of things from text. And I've also previously worked on something called readability assessment. It's just evaluating how difficult is a text to read for a reader, for a given target reader. And there's a lot of work on different kind of text classification, just categorizing text into previously known groups. But on the other side, there is also some work that we do in collaboration with industry. So there is a startup with which I worked until recently, like for the past 1 year. It's a marine startup, but they have a lot of textual data. So our project was more about doing some kind of NLP work in that specialized domain, where most of the existing off-the-shelf models don't really work that well because it's a different kind of language and it's also quite messy. So typically those are the kind of NLP computational linguistics problems we work in NRC.
Okay, so so right now you primarily work with English then, like with your named entity recognition and stuff like that?
With named entity recognition, it's actually multilingual.
Oh, okay.
Because I mean, it's not tied to any industry project or something like. It's more like a research project. So the methods. So I experiment with multiple languages, both for the readability assessment thing I mentioned earlier, as well as the named entity recognition one. But with the industry interface projects, it's mostly English because their data is mostly in English. And there was also one project where I got involved in a French data problem, but then I don't know any French, so that's my constraint.
Yeah, I totally get that.
Yeah, so I mean, you can do whatever you want, but you can't really interpret what is happening because you don't know that language.
Yeah. Yeah, that happens to me a lot because I work with a lot of low resource languages. So it's like, okay, now I need somebody to tell me if this is right or not, because I don't know what it's saying.
Yeah.
I saw in your Iowa State bio that you'd done some automatic text simplification too. Is that right?
Yes, but not a lot. Like when I was in my PhD, there was like, so it was very popular to use standard machine translation techniques to do some kind of simplification of text by treating text simplification as English to simple English translation problem.
Yeah.
So I just used those standard methods on for that problem, but it's not like, I don't consider it like my major research area.
Okay. Yeah. Yeah, that topic was one of the things that actually initially interested me in computational linguistics, because it sounds simple, but it turns out that it's it's like, oh,
yeah,
just switch out words and it'll be better. People will understand. But no, that's not how it works at all.
Yeah, people still work with the same data sets. I mean, I see a lot of papers on text simplification even now, and with a lot of complex methods, but with the same data sets, with the same kind of messy data sets. So I don't know if there is real improvement in terms of the way you're able to I mean, I don't know if we're generating better text than before.
Yeah. All right, let's see. What does a career in computational linguistics look like in the age of data science?
That's it's not, I think it has a very long answer, because data science itself is a very broad term. There are all sorts of roles where your knowledge about computational linguistics may be useful. The most popular role on like when you see social media posts or when you go to blogs seems to be that of a developer, like a machine learning engineer or somebody like that. You do a lot of programming, you know some machine learning, so you build some models. I mean, there is this view that NLP in data science is all about deploying those models. Mm-hmm. But from my experience with working in the industry, I think that's not really true, because you also see a lot of job postings where they ask for people with a degree in linguistics or sometimes applied linguistics, like say Duolingo, the company Duolingo, it posts a lot of jobs where they ask for something like Ph.D. in applied linguistics or something like that. Mm-hmm. And a couple of friends who attended interview with Grammarly said they were asked to do this syntactic, they were asked to draw these syntactic parse trees for sentences and come up with some rules for identifying certain kind of grammatical errors and things like that. So those are different kind of jobs compared to what we have in mind, like a software development kind of job. And there are also other kind of jobs where you the primary role is to create more annotated data resources or to do some kind of quality assessment on the predictions from machine learning models, just trying to inform creating reports on where the model is working, where the model is failing, what are the false positives or false negatives, these kind of things. So all these things are not really about software programming and building models and evaluating them. But still, those building models and evaluating them can't really exist with all this without all these things. And apart from all of these things, one of the other major thing is good communication, like being able to communicate about language processing, NLP, computational linguistics with other stakeholders, which is also something that I think is a part of like a computational linguistics career in data science, but which is not highlighted that much because we don't work in isolation. And this because of the way NLP is being used in many software applications these days, you also end up sometimes talking to different kinds of people. For some time I worked in a newspaper in Canada, the Globe and Mail, and in my daily work day, I used to meet people like, some people used to be like these journalists who go on the field, take interviews with people and stuff like that. Sometimes there used to be these people who wrote interrogative journalism stories. And then sometimes there used to be these other senior editors who wanted some specific kind of functionality. So there are like all sorts of people you meet. Sometimes you also meet these people who do human annotation. They used to have some comment moderators, and we wanted to build an AI tool to support that. So we talk even with those people. So it's not enough if you know how to do computational linguistics. It's important to also know, how to talk to all these people. So I mean, this is why I said it's a long answer. This is how a career in computational linguistics looks like in the world of data science.
Yeah. We talked about at the beginning that I'm getting my Ph.D. in information science with a focus in linguistics. And so I often find myself describing, computational linguistics to linguists, and then linguistics to information scientists. And it's so I definitely get what you're talking about. Like everyone has sort of a different background, but we're all trying to come at this same problem. And everybody needs this kind of technology, like computational linguistics technology, in just about every tech application that there is at the moment.
Yeah.
So in your current position, do you find yourself educating people a lot about what you do? Do you find that you need to tell people like what you do or how it works, or?
So in my current position, actually, most of my interaction is with people with similar backgrounds, except for, so in this, sometimes when I interface with industry projects, there are people who don't come with this background, but they're still technical people, engineers.
Yeah.
And the only time where I actually speak with people without this background is when I teach. Usually, so I mean, I'm not doing these full-blown courses anymore, but I take this courses which last 2 weeks or 3 weeks, where we meet very frequently. It's like a crash course, intensive kind of course kind of thing, where most of these people are students from different backgrounds.
Mm-hmm.
So I think that is where I have to communicate more in detail the most, because other groups of people, it's assumed that they know we have some common knowledge.
Yeah. Do you miss teaching students, or do the 2-week courses kind of fill that gap?
I actually miss teaching, but those crash courses I do kind of fill that gap, because I mean, teaching full time also comes with its own problems. Like you don't get time to do your own research, and then if the class is large, there's a lot of grading to do and stuff. So if I don't teach completely, maybe I'll miss it a lot. This arrangement seems to be good.
Yeah. Best of both worlds, right?
Yeah.
So where in industry do you believe natural language processing has the most impactful application?
So from a user perspective, in my opinion, the most impactful applications of NLP these days seems to be like in search, web search, when you do Google search, when you do like the spelling and grammar correction, things like tools like Grammarly, and applications like Duolingo, where you can practice new language. I don't know how proficient you can get, because as far as I used Duolingo, I never got into like too advanced exercises. I think these are all impactful applications from the perspective of like a lay user. And voice assistants, chatbots, these kind of things, like they used to be pretty bad even when I was in Iowa State. Like when I tried to use Siri, it never got my Indian accent right, but they seem to have gotten better over the years. And nowadays they seem to actually understand. Like I have a 3-year-old, sometimes our Google Home even understands what she's saying. So yeah. So I think those are some of the more impactful applications in terms of everyday life.
Yeah, I have a friend who had to turn her Google Assistant off because her 3-year-old kept talking to it and wanted to know what it was. Like, Alexa, where are you? So
yeah, for my daughter is the weather. She all because I ask about the weather every morning, she wants to ask the same question all day.
What about, forgive me for asking since it's my research area, but what about in low resource languages? What do you think might be the applications for, like the most common applications for languages that don't have as much data available, or that, there are not as many speakers and that sort of thing?
Yeah, so actually, so we have in NRC, there's a large indigenous language technologies project.
Mm-hmm.
I'm not a part of it, but there are several people in our team working on that, and they actually also collaborate with several indigenous language groups in Canada. From the perspective of larger data, they actually do some indigenous language machine translation. There is some Inuktitut to English machine translation system and stuff. But their words, when they present things, the actual applications that seem to benefit those people seem to be applications that involve teaching the language or practicing the language, spell checking, and these kind of things. So those are the applications that seem to be most impactful for low resource languages.
Okay, thanks. What are some of the challenges that the field of computational linguistics still has to overcome?
I think it is, this thing that you just asked, that is a challenge that still has to be overcome, because modern NLP is very data hungry.
Mm-hmm.
More data you have, and it's like everything is deep learning these days, and all the deep learning models require lots and lots of data. So what do we do in low resource scenarios? One option is like people train like these large language models on hundreds of languages, and use something called transfer learning. So you have a small amount of data in your target problem, and you take this large pre-trained model, just tune that model to work on your problem. But then the problem is, like, even if this pre-trained model has 100 different languages, you still have some kind of imbalance in the language representation. Like English has a lot of data, but say some other language may not have that much data. So there will be a bias all the time.
Yes.
So I think that is something that is like an open problem even now in NLP. And the other one, I think, is generalization. Like if I train a model on, say, a lot of newspaper documents, will it really work when I apply the legal text? I don't think there is a clear-cut solution that works for everyone yet for that kind of problem. Unless, like, for example, I take a name entity recognition system which is trained on news text. I start applying it on legal documents. It won't work as well.
Right.
So then what is the solution? Like, if I can't keep creating large data sets for each and every sub problem I encounter, right? That's again, like, creating the data set is also a problem. So how do you generalize without, despite these differences? So that's, I think, another challenge we still have to overcome. And so just yesterday, when you asked me for how to pronounce my name, I was looking for the phonetic transcription on Google Translate, and I noticed something strange. So when I was typing my name, the transcription was fine, the pronunciation was fine, but what I was seeing in the translation tab, like from Telugu to English, that was something interesting. Like each time I added a space or I added a hyphen, it was showing a different translation for me.
Mm-hmm.
Although it's like, it's just a name, and I can't have so many different translations for my own name. And then it translates my first name, but not last name, or sometimes leaves my first name and then translates my last name. So that's also something which I didn't realize is such a big problem until yesterday. like just inserting punctuation characters seem to change the translation a lot.
Mhm.
And nobody understands why, because there's a lot of like these neural machine translation systems are like very opaque. They're like black boxes.
Mhm.
You send something in, you get something out, and that something you get out is sometimes very good, but we just don't know why it is good or why it is bad. So I think that's also one of those ongoing challenges in the field.
Mhm. What about bias? So something like, I know there was a case in where everyone online was pointing this out recently, where in Turkish, if you would ask for a Turkish translation of doctor, it would automatically give you the masculine form of doctor. And if you ask for nurse, it would automatically give you the feminine term.
Yeah, I think it happens also when I translate from my language Telugu to English.
Mm-hmm.
I think it's like there's a lot of discussion these days on that bias on towards of gender or racial bias in these machine translation models, general NLP models, natural language processing models. And there's also some bias towards like some nationalities are some religions are overrepresented in the data set, and then you don't see I noticed this because some time back somebody reported I was a part of some social media discussion, and then it turned abusive. Somebody was reporting other people like this comment is abusive and so on. And then there was like one place where the religion was interchanged, and then suddenly the comment did not become abusive anymore according to the automated system. Like I don't remember the exact religions. Like one person commented on Islam and it was abusive, and then that was changed to Hindu, and then that didn't suddenly become abusive comment. So those kind of things still exist, and I think it's a major issue. But people are also working on how to quantify that kind of bias in machine learning system. I mean, it's a general problem. It's a machine learning problem. It's not specific to NLP.
Sure.
Because we also hear cases like this in computer vision, where like images of some race are biased against compared to some other race and so on. Sorry.
Yeah,
so I think it's an ongoing problem.
Yeah, especially in language, when you train data on biased language, of course, you're going to get biased models.
Yeah, exactly. Yeah.
Yeah. So what are some recent advances in the field of natural language processing that regular people or consumers might not be aware of?
They are mostly, I think, the advances in natural language processing seem to be very tied with advances in machine learning and deep learning these days. So the two things I found very interesting that we probably don't notice that much as end users are. So the first one is efficient models, building efficient models. Like models are becoming, previously language models used to be huge. And you deploy them on cloud, it's okay. So you don't see what is happening. But then large models also require large storage, and then you have to ping the model many times and so on. So people are focusing on making those models more compact, and also working a lot on having on the device models. Like instead of pinging a cloud, sending all our data to a cloud location all the time, like you have your own model on your phone. Your data is yours, and it gets trained. The machine trains based on your own language use. So that's something where there is a lot of work going on, which we don't notice we notice only for this model is doing better in terms of like, are we able to write better because of this Google spell checker or something like that, but we don't really know what is happening. Why are we able to write better compared to before, right? And people are also talking about green computing, like reducing the carbon footprint of these models. But I don't know if that's going to be solved anytime soon, because just last week, there was a blog post by Google on some super large language model, which I mean, if language models are that big, obviously they're going to also have a big footprint.
Mm-hmm.
And yeah, I think, is there anything else? I think in terms of like the way the models are being trained, I think there's a lot of innovation. Like, so there is a lot of multitask learning going on these days, multitask and multilingual, instead of just doing one pair, like English to French is a separate system, French to Russian is a separate system. Not like, instead of that, like there is one system that learns everything. So there was also like some work last week or so on speech-to-speech translation with multiple languages. So I think that's also something that is happening a lot in research right now, which will eventually make the products that we use better.
Mhm. Yeah, that's interesting. So what and I think we've touched on this a little bit, but what ethical issues come up in the field that require more thought and discussion in your opinion? Do you have any suggestions about how to overcome them?
Overcoming them, I don't know. Like, I mean, I've often thought about this. Like, can they really be overcome? So one way is to, obviously create more diversity in the data.
Mhm.
Like say in that example with Turkish gender, creating more examples where like say a doctor is both a male and female, that's a solution. But then first question is, how will you create those examples? And the second question is that will just make the training data even bigger.
Yes.
And training the model even bigger. So I mean, I don't know the solution yet, but I think that is not the way to go. Maybe we should think of some other way, like, models that can cherry pick their examples rather than just looking for more of the same kind.
Mhm.
So maybe there should be some change in the way, in the learning paradigms that we have and the machine learning paradigms that we have. Instead of looking at more number of examples, there should be some way to figure out sampling more diverse set of examples and learning from them.
Mhm. Yeah, asking how to fix say the gender problem in NLP is like asking to fix society, right? It's like, how can you personally make gender bias go away or racial bias go away, because we use data that people write, and so it's really hard to remove all bias from that. And then if you do, you're just making artificial data sets, and who says that artificial data set is real natural language? Yeah. That's definitely a big problem. All right, so you've co-authored a book recently, and it's called Practical Natural Language Process, a comprehensive guide to building real-world NLP systems. And in your book, you and your co-authors guide people through the process of building real-world NLP solutions embedded in larger product setups, and teach them how to adapt solutions for different industry verticals such as healthcare, social media, and retail. Can you give us a summary or give us some of the highlights of your book? Maybe you'll have some people go out and buy it.
Yeah. So we wrote the book usually when we look at courses like academic courses in NLP or textbooks in NLP, they focus primarily on one aspect, that is how to build a model, how to provide a solution for a task. However, when we actually start using NLP to build some application like in a job, in an industry position, that's only a part of the entire pipeline. You need to think about how to collect the data, how to clean it up, how to annotate it. And then you think about how to model the data, but then you also think about what are the different ways of evaluating an NLP system. How do you compare multiple things, and how do you deploy it? What happens when you deploy that system? Like people start using it. What if they find out new errors? How do we update this system? How frequently should we do it? So these are all many different things. There are many different things, but our textbooks tend to focus more on just how to develop a solution for a problem. I mean, it's not wrong. It's a big field. Like there are like 20 different main problems in NLP, and there are only one or two courses that people take during their studies. Mm-hmm. But like the book is more about bridging the gap between academics and practice. Mm-hmm. And we also talk about how there are many different ways of solving the same problem. Like say, usually like in a company setup, you start with building a minimum viable product and then incrementally go from there, getting feedback from people start using it. Then you start, so often like, deep learning, say for example, is the first thing you use as a researcher on a new problem. Mm-hmm. But maybe regular expressions or something like that, very simple, very basic things are the first things you use in an industry scenario. Yeah. So that's what we try to talk about in the book, just to make those kind of comparisons and look at like if there is a problem, how do we approach solving it, and what are the many different ways of solving it and things like that.
Okay. Do you think there's any So I guess there's then a gap sort of between what we learn in school and then what we need to learn on the job. Do you think there's any other things that, that people need to maybe work on while they're in school that might help them get into industry? Or
I think there are a few things that we don't really focus on when we are in school.
Mm-hmm.
Like say things like in these kind of jobs, in computational linguistics jobs, like I mentioned earlier in the very beginning, there are many different things you may have to do apart from just building a model and writing a lot of code.
Mm-hmm.
And those are the other things are not really given that much focus in our traditional education, in my opinion. Like say things like doing some project which involves collection of data yourself. That is something we don't usually do in computational linguistics courses, or talking to a different kind of audience about the kind of work you do.
Mm-hmm.
So something you don't really do. So I think those are the things that people who are studying right now can focus on, like instead of just taking a ready-made data set and a ready-made problem and doing a project out of it, maybe you can think beyond that and go through some end-to-end process of just looking at a new problem, figuring out some way to collect data, and then do a model and then put it up somewhere, then maybe give a presentation about it or something like that.
Mm-hmm. It's really interesting talking about that, because one of the things that I'm actually working on this semester is using web data as a resource for corpora for low resource languages. And so looking at things like web crawls and web archives to be a source for data. And so it's really interesting when you start looking at building a corpus, because there are so many things to think about, and it's kind of intimidating, like all of the different things that you'll have to do to make it fair and balanced. And it's interesting.
Yeah, and sometimes it's also like you may not even have rights to crawl the data. Like sometimes, you can view that website, but then they don't let us crawl the data. But that's also a problem with NLP actually. Like people put up all sorts of data sets, and we don't really know if, it's okay to do that.
Yeah, that makes me think of Twitter data. You can only
exactly
tweet IDs instead of entire tweets. And just for everyone listening, that's because Twitter wants Twitter users to be able to delete their tweets. And so if you release a data set with someone's tweets in them, they lose the ability to delete the tweet. And so Twitter says when you release a Twitter data set, you can only release the ID numbers of the tweets, and then you have to go back and retrieve the tweet. All right, so I think we have one more question. And so the first part of the question is, what advice do you have for people who want to get into the field of computational linguistics? And I've been asked to do a shameless plug here, because of course, one thing you can do is, get a BA in linguistics and an MA in linguistics from UNT with a concentration in computational linguistics. And then of course you can do the PhD that I'm doing with the linguistics concentration. But what are some other ways that students can prepare themselves for getting into the field, either in academia or in industry?
I think there are we see all sorts of people when you visit a typical NLP conference, or when you meet people in the industry, you see like many different kinds of people coming into NLP, like more compared to like say 10 years ago. 10 years ago, most of the people you see either have a background in linguistics or computer science. Mm-hmm. But nowadays, like you see people doing NLP with a background with a bachelor's degree in physics, or sometimes like some social science degree, journalism and things like that. But I think a common strand for all these people is they have some strong domain knowledge in some other domain, but they're also good at software programming. So I think the role of linguistics in these people, the kind of people that I see in more technical jobs, is less compared to the domain knowledge that they have. Like say, I study political science and I can get into NLP, data science and those kind of things, and work on problems that leverage my knowledge of political science. Mm-hmm. So like a regular NLP engineer can't come and solve that problem, but I can do it because I'm a political science person with an NLP background. Mm-hmm. So that's the kind of path some people take to get into this field. And some people also come from a pure linguistics background, but the nature of jobs are different. Then, like there are jobs for linguists and which focus more on data annotation, quality assessment, and those kind of things that I mentioned earlier. Mm-hmm. So I think that's another path. But in my view, if you want to get into some kind of computational linguistics, NLP area, it's good to have some proficiency in programming languages, like one or maybe two. And this is even more important than having a strong, I mean, you don't have to be very strong with, deep learning, machine learning, and all these things, because there are all sorts of jobs in this area. Not everything is like hardcore engineering focused. So I think whatever career path you take, make sure that software programming is a component in that. And also for people who are starting out, maybe it's good to cast a broader net across these jobs rather than say, I want to do only this one, this kind of job, like say, I want to do this linguist in Grammarly only and not anything else.
Yeah. I had a question and now I've forgotten what it was. I see Lisa's back too. Lisa, do you have, are we moving on? Are we asking?
Well, I'm ready to take any questions that anyone wants to put in the chat. So far, no one has put a question in there, but I do have a question. And my question is, so my background in linguistics is the teaching side, applied linguistics. And I've taught ESL for many years. And of course, through that, I've learned a lot about languages and how languages work just through my students. What would somebody like me need to do besides learning some programming languages, which really scares me? I remember in our webinar, Kristy, that you said any Python is better than no Python. I remember you saying that. And at the time I thought, I guess I need to start learning some programming languages. Is there something I can do without taking a formal class? I'm not ready to go jump back into a program yet, but are there places to learn programming languages?
Oh, I think there are definitely online courses to learn programming, even for people without any background in programming. I mean, for all sorts of audience, basically.
So low risk, right? You're not paying a lot of money and you're not.
Yeah, no, most of them are also free. Like you also find a lot of research, like learning programming, general programming itself is like, you find a lot of free resources for that online. But in terms of like, where can you, as a ESL instructor, where can you use NLP kind of computational linguistics kind of stuff without being a proficient programmer? Actually, there are many tools that people use in language instruction, like say these tools like Grammarly or ETS, Educational Testing Service, has a couple of other tools like for giving this style guidance when people are writing technical articles. Mm-hmm. And some pronunciation training tools. And then there are some assessment tools like these language assessment tools or speech assessment tools. So there is a lot that instructors can do in terms of using these tools, figuring out what is a good way to use these tools for. I mean, using these tools do not require you to program yourself, but it's good to have some knowledge about what is going inside the tool to be able to use the tool properly for the class. And I mean, like applied linguistics researchers also do a lot of stuff. Like in Iowa State, I worked closely with these applied linguistics researchers. So they used to do also a lot of research with these tools, which don't require hardcore NLP, but they did use a lot of, like, they used to write a lot of programs to do some kind of corpus analysis and discovering patterns in the student writing and these kind of things. So those are the kind of like low intensity programming stuff that will still benefit you when you're doing this language teaching related activities.
That sounds good, because my fear would be that I'd take a programming class and, pay a lot of money for it. And halfway through, I'd be like, I just can't do this. I just can't. So
I actually have another UNT plug for you. So the UNT libraries teach a course that's called Software Carpentry. And that's an organization that has a certain set of lessons that can teach you how to do use certain computational tools. And UNT libraries actually offers software carpentry classes. And so you could go and take very introductory Python, very introductory R, And it's just like a 4-hour lesson. It doesn't cost anything. And so those are actually pretty cool. I have taught those in the past, and I'm not sure if she's still here, but one of our viewers is actually the head instructor for UNT libraries, Lauren Coe. So yeah, there's ways at UNT that you can go and learn some introductory programming too.
Okay. Dr. Selman, did you have a question? Is that why you turned your camera on? No question? I'll go ahead and read the question out of the chat. So we do have a question in the chat, and then you can, if you do have a question, you can get to it next. So in the chat, it says, Sandy's asking, in your research, do you uncover or discover cultural trends?
So I don't do that kind of research, but it's possible, like people do a lot of this culture analytics kind of work using NLP methods. And there was also, there was this Google Ngram Viewer application that also, where you can see historically how the usage of a word changed and those kind of things. And not really cultural trends, but I did notice something recently in one of my work. So I was doing this, analyzing this name entity recognition data. And when I changed all person names so I changed all person names from English names to Thai names, and then the performance dropped a lot, which I found very strange because like, I mean, ideally this NLP model should be learning the patterns, like the surroundings in which a name appears, not the name itself, right? So when we just change so there is this Python library called Faker, which allows us to change names by nationalities. So that was what I used to try this out. And there's a huge difference when you change from, even from, English US to English Ireland, there's a huge difference even in that. And then if you go to Thailand, or if you choose Indian English and those kind of things, like there's a lot of variation, like in terms of system performance. So, I mean, it's not exactly cultural trends or anything, but it's still related to, like, the names are also a part of our culture. So it's still related to how the systems perform across different names, with names across different cultures.
Mm-hmm. Thank you. Thank you for that answer. And I see that Dr. Salman just wanted to say thank you for this fascinating discussion. And Adam has changed it so that you can unmute now if you care to. And also Dr. Coe has put the link to the library in the chat based on what you said, I believe, Kristy. And let's see, we have another question in the chat. What are the fundamental differences between natural language processing and computational linguistics? That's a good question. I don't know that answer either.
Yeah, and so people sometimes use those terms as if they're synonyms. I mean, I do it all the time, but primarily, like, the difference is, so computational linguistics, the name came up as like a truly interdisciplinary endeavor between computer science and linguistics, where people used to do this grammar engineering, build grammars using a lot of linguistic rules and those kind of things. Whereas modern day NLP is more like, give me a lot of data, I will build your model for you. You don't really need a linguist. So natural language processing is more focused on that kind of work, like more like data-driven work, whereas computational linguistics is more focused on expert knowledge, domain knowledge, building a lot of heuristics, rules, and then building a system from there. So primarily that's the difference, but most of these conferences in NLP are called some conference of computational linguistics, but we all publish and call ourselves as NLP researchers.
Okay, thank you for that answer. And now we do have a question from Dr. Salman. I think it's a question. He says a lot of language meaning is inferred, so not part of word meaning, syntax, etc. Have you worked on projects that deal with implied or inferred meaning in texts?
I did not work on them myself, and it's also like some kind of open problem in NLP. I don't think there is a clear ready-made solution in terms of like whether we can infer meaning from text. So some of this research on these large language models by organizations like Google and Microsoft, they try to tackle this question by asking some complex question and say, like, for example, with this last week's language model that Google released in their blog post, they have this example where they say, here is a joke, explain this joke for me. And then the model gives some explanation saying, trying to give some kind of implied meaning in that joke. So, I mean, they of course cherry picked that example. I'm sure about that. So we are not there yet, but there is some work going on in the field trying to do that kind of stuff.
Dr. Salmon, since you're here and you know the programs that we have in our linguistics department, are there any programs you would specifically want to highlight that might get us to where Sowmya says we need to be with our natural language processing and computational linguistics skills?
Oh, well, with the programs with the concentrations in computational linguistics, for sure. I mean, that would be the place to start with what we have to offer.
And have you had a chance to look at the, so one thing that we have here at the College of Information, which is great, is that we have these interdisciplinary crossovers. You know, we have an information science department, and then we have our learning technologies department, and we have data science department, well, under the information science department, and then linguistics. So students can really learn what they need to learn for computational linguistics, not just in the linguistics classes, but they can even go deeper. I wonder, Kristy, have you had, which classes have you taken in the information science department that have really been useful in your linguistics, computational linguistics endeavors?
So the information science department offers some Python courses. I didn't take those, I took one, but it wasn't necessary, but I took one just to see what they were like. And yeah, so the College of Information offers a number of courses to sort of help you learn Python. So if you actually want to do computational linguistics, but you're coming into it with no programming background, there are a number of courses where you can learn different data science techniques and learn how to program, and especially in Python. And I don't think we have any courses that teach R, but you could always take a software carpentry for that if you want to learn to program in R. So yeah, I think that's especially, I think those are the best ones, are the data science courses and the programming courses in information science.
Okay, excellent. Well, we're coming up to the end of our hour here, and I don't see any more questions in the chat. So this is your last chance while we have Sowmya here with us and Kristy here with us, and the chair of the linguistics department, if you have any final questions. And you can feel free to unmute and ask your question directly if you care to. No? Okay, well then I would like to thank both Sowmya and Kristy for being here today. It was a fascinating discussion. I learned a lot, and it's just made me more interested in, you know, going past my master's in linguistics to the next step and adding some computational side to it. But first I have to maybe try out those library classes to see if I actually have any skills, any natural skills that can be applied. So thank you so much for coming. Thank you so much for your discussion. It was really great.